Welcome everyone to this live session of hydraulic engineering. My name is Mohammad Saud Afzal. I am an assistant professor at Department of Civil Engineering, IIT Kharagpur. Today I have with me my two teaching assistants, Mr. Subhranshu Purkayastha and Mr. Lalit Kumar. They both are PhD candidates at Department of Civil Engineering. So our modus of operandi today is going to be to first start with the issues that you have put up on the Excel sheet that was provided to you when the live session was declared, and then if you have further questions, then we will take it up one by one. So I think let's get started. So the first doubt that you had, that in the assignments, when you solve those assignments, in case of string or numeric values, if you put in blank spaces, then the online correction tool has some problems. For example, I will tell you what I intend to say. Going to the whiteboard now. For example, if the answer is streamlines in continuation, and if you type stream and if you put a space in between, so normally this should be also correct. Of course, this is correct, but this should also be correct. But several students have complained in the forum that this gives an error and you are marked, you are not being given marks. So we will raise this issue to our web team. Hopefully this should be resolved soon, and whatever be the outcome, we will let you know in the forum. So now going to the second doubt, somebody has asked, actually Mr. Anish has asked about the solution of the assignments. I would like to take your attention to the fact that we provide solutions to the entire assignments. It should be available on the online portal. So please go and look at the detailed solutions available. The third question is by Mr. Varun Gupta. Mr. Varun Gupta has asked something about the value of du by dy. It was just mentioned this, but I think this is more about more related to the Newton's law of viscosity. Where you have to calculate tau is mu du dy. So the question is, why do we put the value of u? So basically du can be written as u2 minus u1 and dy can be written as y2 minus y1. So in case of uniformity, you can simply put u2 minus u1 divided by y2 minus y1, because this is nothing but delta u and this is delta y. So if you put in these values, you will be able to obtain the value of du dy, and this shall solve you the problem. This is from the week 1, basics of fluid mechanics 1. So the next question that we have is from the boundary layer. Ms. Shanti Priya has asked, actually not much is written, it says something about, just says boundary layer. So boundary layer is the ongoing topic this week. I think whatever doubt you have, if you can be very specific, we are online now, so you can ask right away, or but in general boundary layer you can go through the slides. We have solved many questions also in that, and hopefully that should clarify your doubts. So question number 5, Mr. Marru Srinath Rao has asked about open channel flow. What is an open channel flow? So to start with, actually we are going to cover this in detail in week number 6 and 7, but just to tell you, open channel flows are those flows which are majorly driven by gravity, okay, and where the surface is exposed to the open atmosphere. So those are the open channel flows. One of the most common questions that you are going to face regarding the open channel flow and pipe flow is, what is the difference between open channel flow and pipe flow, which we will come back to it again in week number 6, 7, 8 and 9, where we specifically deal with the open channel flows and pipe flows. So, the difference is, in open channel flow the flow is governed by the gravity, whereas in pipe flow it is the pressure gradient that drives the flow. That is one of the most important difference between the open channel flows and the pipe flows. All right. So, the sixth question on the list is by Mr. Shashi Kumar. Mr. Shashi Kumar says, more number of example in numericals. I think we have solved numerous examples in the during the lecture itself. I think not less than 8, 9 per week, and whatever those whatever those examples we have solved, this should be good enough to score 100% marks in your this particular course. So, no questions that will be asked will be outside what the concepts that are being covered in the theory and also these examples that we have done. So, my recommendation to you is go through those problems in detail. If you have any specific doubt that why did we do this particular step, then you can come, either you can ask it today in the online live session, or you can also do it in the next session, which is scheduled in the month of March. Okay. Now, Mr. Anish Jangir has asked about hydraulic machines. So, this particular course we are not covering hydraulics machine. So, it is not in the syllabus directly, but the concept which guides the hydraulics machines are being covered in terms of basics of fluid mechanics 1, 2 and whatever topics that we have covered until the end of week 12. The next question that we got very recently was the stream, how are the stream functions and the potential functions related. So, I would like to take your attention to the whiteboard that I am going to use. You know that the velocity u can be written as in terms of velocity potential as del phi del x, and also this can be represented in terms of stream function as del psi by del y. Similarly, the velocity v can be written as del phi del y, and in terms of stream function it can be written as minus del psi del x. So, this is the relationship between the streamlines and the potential function. So, I am going to So, another question that we have is about the surface tension at the interface. So, what as far as I understand, this surface tension at the interface so, let me see if I have the exact question here. I am unable to see it right now. Can this be posted to my screen, the exact question? Refresh. So, the question is surface tension occur both adhesion and cohesion. Okay. So, actually the question is not very clear, but just telling you about the adhesion and cohesion. Cohesion is between the is in between the molecules of the water, whereas adhesion is in between the molecules of the water and air. I hope that is good enough to be to clear your doubt. If you have more specific, then you can post again. All right. The second question is, can you make the assignment completely MCQ type so that you can avoid conflicts in correction? Yes, this is the topic that we have discussed right in the beginning of this live session. We are actually going to discuss it with our web team, and we will see what can be done. The best way is to resolve that string problem. I mean, if you insert a line, a blank space or a line, it should not normally the answers should be correct. So, we will discuss it with web team and let you know in the forum as soon as we can. This question was by Ilamurugu Bharadwaj. The third question is by Charlie Krum Music. Yeah, please sir, help, my scores not satisfactory, but I have watched all your video. Assignments are tough actually. Our assignments are a mix of simple questions, easy questions, very easy questions, difficult, and some of it, as the last 10% maybe as you said are tough. But do not worry, try to revise your before attempting the assignment. You should be revising your slides and the lectures maybe once or twice. You will do, see, it's only 4 weeks until now. So, you have 8 more weeks to perform well. We can but I am pretty sure that after completing all the assignments of the course and revising the basics, you will do really well in the exam, but you have to score that bare minimum in the assignment that is actually required. So, if you attempt all those, and I think not all the 12 assignments will be counted, there is something where you best 10 or best 8 something, some numbers out of those assignments will be counted. So, if you scored bad in some of those, do not worry, try to do well from the next time onward. If you repeat it, revise it twice, it should be good enough. So, Charlie has come up with another query, says I have made notes too. This is really good. So, if you keep making notes as the lecture and the slides progresses, this will help you. So, make notes, revise twice, and I think it should be good for your revision as well. Very nice. So, students, please come up with any specific questions and queries you have regarding any of the things you have come up within the course. This course carries practical significance who are planning to make their career in hydraulic related branches. So, this course is not only specific to civil engineering, but also in the field where you will, for example, if you go and also start working in a pipeline company or a petroleum company, these formulas that you are going to learn in courses like open channel flow, especially pipe flow, will be required all the time, like the Darcy, V batch. We have not talked about it, but as the course progresses, you will see the real importance of these topics. So, you can ask more doubts now. So, there are 3 new topics in this course which has never been before. So, one of the courses viscous fluid flow, which will strengthen your concepts in numerical modeling or even analytical modeling, and discusses the derivation of the Navier-Stokes equation. Navier-Stokes equation is an unsolved problem. The analytical solution of Navier-Stokes equation is an unsolved problem from last 3 centuries. So, somebody who solves that is definitely going to get either the field medal or in terms of physics they might also be getting Nobel Prize. I am not sure which one, but definitely it is a. So, we have introduced viscous fluid flow, we have introduced computational fluid dynamics, first time at the level of undergraduate studies, which is something that is vastly growing. It is common to civil engineering, mechanical engineering, aerospace and chemical engineering. This new topic, computational fluid dynamics, it will give you a broad idea. And the third one is in viscid flow, solution of Laplace equation in terms of wave mechanics. So, I think those topics are also really important. Just to go back at the Navier-Stokes equation, it is actually a millennium problem. If you solve that analytically, you will get a prize money of $1 million US. So, something to get motivated about. So, students, do not hesitate, come up with more questions. So, the Ila Murugu Bharadwaj has asked, is the laminar and turbulent flow concept same for fluid and heat? See, these concepts is actually, heat is what? Heat is an energy, right, and fluid is a matter, all right. But if you want to ask about, fluid is a general term. I mean, I think you wanted to ask if it is same for air and water. If that is your question, then there is one difference, that the basic concepts are the same, but water we treat incompressible, where air is compressible. But I mean, for fluid and heat, heat is, heat involves one extra equation, and the concepts are the same. So, any flow is laminar in which the Reynolds number is less. Turbulent flow, Reynolds number is very high, and actually in turbulent flow there is energy loss in terms of heat. So, probably I think you wanted to ask this particular question, and probably you could not formulate it really well, but Ila Murugu, I think you are online and you can, I mean, tell me if I am right, or if you wanted to ask something else. See, your final exam will be a combination of, some questions you are going to get also from the assignments, some questions that you have not seen, but rest assured some of it will be very easy. Passing the course, if you know the basic concepts of this course, is not going to be a problem at all. So, my suggestion again to you is revise the, you can watch the lectures as many times as you want. One thing that you can do, you see I have given you some reference book. So, the book by Professor Subhashish De has all those concepts covered in depth and detail. Also the book by Professor Som. If you go through those books, it will give you more details about that. Also you can refer any fluid mechanics books and try to solve the problems that are covered there. First start with solved problem, so do some unsolved problems from there. So, yeah, I think we have another question by Love Kush, which says that it's covered all the syllabus of GATE. Yes, we have covered everything that is there in the syllabus of GATE, leaving the hydraulic machines. Because the AICTE, I think that part about hydraulic machines, it would be better if you can go through it. It is only one single chapter where you need to solve some simple numericals. And yes, so yes, I think Lavkush has said, sir, I have Dr. Bansal fluid mechanic. Oh no, it's Charlie Chrome Music who said, I think Bansal fluid mechanics is as good a book as any other. So, if you read it from there, solve some questions which are discussed, will give you a good practice, and definitely you will improve your marks. So, major percentage of the marks will be from your exams, the final exams. I think it is sufficient, yes. Any one book, you just pick up one book. So, the reference books that I have given you will give you more detailed, and if you feel enthusiastic about some other topic, you can refer the book by Professor Subhashish Ray and also the book by Professor Som. Professor Som's book covers the basics of fluid mechanics, but to go into the detail, I think the book by Professor Subhashish Ray is much more detailed. So, Ila Murugu Bharadwaraj said, because we consider Reynolds number for convection problems, I thought heat and fluid were analogous with respective to flow. So, by heat, see heat, I am really as I said, the concepts are the same, but when you talk about heat, heat is not a matter, heat has to be transferred through something, right, through a medium, and that medium is generally fluid, whether it is air, water or any other fluid. But again stating the basics are the same, but connection or heat transfer, I mean the heat transfer is more relevant in studying transport processes. So, when you, I think it is after week 8, I think so, there is a chapter in this topic, that is viscous fluid flow. There I have specifically told, in reality you have to solve the continuity equation, the momentum equation, and then there is a heat equation or the energy equation. So, if you want to do the transfer, the heat transfer and everything, you have to solve the energy equation as well. But this particular course concerns the fluid like liquids. So, we skipped that part and mainly made it for people specific to dealing with water. Because I think that particular problem, if you include the heat transfer through energy equations, I think that is more up to a level of masters or a PhD course. So, Ilamurugu, I think I have clarified your doubt enough. If there is something, you can again put a query. So, the question is, I think Love Kush has posted again, surface tension is occurred both adhesion or cohesion or only cohesion. See, adhesion is in between the molecules of water and air, all right, and for the surface tension at interface, cohesion is in between the molecules of the water itself. Yeah. So, okay, maybe I should draw this diagram. So, basically let us say this is the, and this is one molecule, and this is air, this is water, these are the water molecules, right. This is the interface, maybe this will clarify, this is air, these are, let us say I will put dot as air molecules. So, so for this particular water molecule, the attraction between them is called cohesion, but if it is attracted by this is adhesion. I hope this clarifies. So, we have another question. So, Uday Gowda, sir, in assignment 2 you asked to calculate both acceleration and velocity component, but the correct answer shows only for acceleration component, shows only for acceleration problem. What about, let me see the entire question. Okay. So, I will actually we will check it with our web team. If there is any problem, we will get it sorted out soon, maybe in a couple of days time. Uday, if you have any other questions, you can ask. So, do we have some faculty members also here? So, Lavkush has asked another question, says because some notes it is clear that surface tension is occurred only cohesion. So, I think if you do you refer to my notes or some other professor's note or some other book? If I have said that, then please specify the lecture number and the time at the video. We shall clarify this in the forum. If I have said this during my lecture, I will clarify it. I mean, we will put a rebuttal in the forum, but if it is from someone else, then you can also specify it there. We will double check and also clarify your doubt. So, going to the question number 2 by Ila Murugu Bharadwaj, he said, can you make the assignments completely MCQ type so that you can avoid conflicts and corrections? I think the exams that you have is more robust. Most of the questions are MCQ type there. So, Sagar has asked another question. So, actually his first question, and he says, sir, what is the relationship between the stream line and the velocity potential line? First of all, you should understand, I am going to tell you about that, but more importantly what we can do is, first you should understand what the velocity potential and the stream function is and its relation to the horizontal and the vertical velocity. Then I will come to the concepts. Okay. So, basically the velocity u is del phi del x, and this phi is velocity potential. Okay. And this is equal to del psi by del y, and this psi is a stream function. I will come to the line that you have said, and v is del phi by del y, phi you know what that is, minus del psi del x. All right. So, as already covered in the lecture, you can say that del phi del x into dx plus del phi del y into dy, whereas del psi can be written as del psi by dx into dx plus del psi by del y into dy. So, you see, if you retort to this method, you can write del phi is equal to minus u dx minus v dy, and d del psi can be written as v dx minus u dy, okay, and dy by dx, sorry. Minus u by v, and that is, let us say, slope m1. And from the other relation, this relation I am taking it here, you can write dy by dx is equal to v by u is equal to m2, and you can see m1 multiplied by m2 is equal to minus 1. This can be relation if you asked about it, or orthogonal. Okay. So, I think we have another question. Sir, no. So, Charlie has said is the main exam is subjective. No, I think it is subjective if you mean to say you have to write the detailed solutions. No, it is mostly will be going to be the MCQ type or true and false, as far as I remember. So, it is not going to be subjective. Lavkush has asked again, sir, my sum question is true in assistant 1, but in solution my question is wrong. Okay, yes. So, I think you are referring to those the string, I mean the problems that are happening because of the strings and the numeric values. So, assistant means assignment 1, I think in Hari you have written assistant. So, but your solution means when the computer corrected your answer, some of your, okay. So, now you have said some of my question assignment were wrong, but I had written them right. Example streamline, yes, that is true, and I think the same question is from Lavkush as well. So, so this we are going to discuss with the web team. If they are able to solve that, see, I do not promise if they will be able to resolve that, but I hope so, that will be resolved. But do not worry, from the next assignment onwards we will take care about it. So, from assignment number 5 onwards, if at all there has been any errors like this will not happen, we will double check it. So, that try to avoid things that create problems like this. Yes. So, Charlie and Lavkush, I think we have got your message about this, the questions in the assignments. So, do not worry about it, you still have 8 more assignment, and if something can be done about the questions that you have done before, we will try to correct it, if it is possible. We will talk with our web team and you will be notified about it in the forum. So, Ila Murugu Bharat has asked, can you give physical example of 1D, 2D and 3D flows? All right. So, actually in real life all the flows that you see are 3 dimensional in nature, all right, but you are asking physical examples for 1D, 2D and 3D flows. There might be certain cases in which the flows might not have 3 dimensional variability. That means the velocities in 3 directions will be different, all right. So, for example, if you have a infinite domain in y direction, the velocity is not going to change that much in that direction, and that can transform your problem into x and z. Similarly, if there is no variability in z direction and the flow occurs only in one direction, either x direction or a radial direction, those are 1D. So, some of the examples are 1D will be flow through a small diameter pipe, where the velocity will vary only in the radial direction. The second is 2D, circulation of a water in a shallow tube, for example, all right. If you take the length of the flume in y direction very large, then the velocity will vary only in x direction and z direction. And 3D, it could be any flows, a normal flow in the river or oceans is a 3 dimensional flow. So, Ila Murugu, I think you have got, but I think I might have talked about it a little bit in my slides as well, maybe it will come up later. Good question, Ila Murugu. So, can we take blood flow as 1D? Yes, that is true. See, the flow is laminar. So, because of the low Reynolds number, it can be simulated as a pipe, laminar flow in pipes. So, blood flows in arteries, veins. So, but practically speaking, the diameter of the arteries and the mostly arteries is so small that the Reynolds number is very small, and the flow is practically laminar, and it will simulate as the laminar flow in pipes. Therefore, it can be assumed one dimensional. Good question, intriguing question. So, today we have taken up 18 questions until now plus 8 from before, that means 26 questions. If you have any further questions, so probably we have a question 19th question for today. See, so we have a question from Sagar, Sheed Sagar, and the question is, sir, can you give examples of rotational and irrotational flow? See, rotational flow is something that happens in nature, all right, and whatever problem that we solve, whatever flow, it is technically rotational, but under the lab conditions we can create irrotational flows. And for irrotational flow, I have told you the formula omega is equal to 0, all right, the rotationality constant. So, one of the clear cut assumptions of the for example, an open channel flow in the lab where we have laminar flow, for example, any laminar flow is irrotational in nature, and any turbulent flow for that matter of fact will be rotational, any turbulent flow. So, for example, tsunami, that will be rotational, and irrotational will be calm water flowing in a pipe, a laminar flow. And to be more specific, so yeah, for flows, if there is phi exists, it is irrotational, yes, that is what I already told you. All right. Something more? So, Charlie, I think we are going to talk about what is surface solitary wave. So, okay. So, first of all, you look at the definition, surface solitary wave. Surface means the waves, I mean, so something that occurs at the water surface, that is surface. Solitary means single, and wave means wave is, as for example, a sinusoidal disturbance that travels. So, surface solitary wave is one single sinusoidal signal that travels at the water surface, all right, and we will come, we will study about it in week 6 and 7. I think there is no point in jumping ahead of the schedule, and we will study more into detail what that is. We have a full half 30 minute, I mean one full lecture, 30 minutes lecture dedicated to the derivation of surface solitary wave, where we will not only use the momentum equation, but the energy conservation equation to derive those formulas, what is the speed of surface surface solitary wave, and in the end we will have general derivation of the waves. So, I think it is almost time. We have spent good 45 minutes in the discussion. Any last questions that you have, or it is no problem, you can ask in the forum also, but also we have next session coming up somewhere in between 10 to 14th of March. I do not exactly remember the date, but in the first half of March. So, Sagar has asked another question, sir, what is flow net? So, flow net is a network of streamlines and equipotential lines, which you will not be asked to draw, but you should know how to draw that. If you can draw the streamlines and the equipotential line, that network is called the flow net. It is typically covered in more detail in the master's level, but since this course is the exam is not going to be subjective. So, I am not going to ask you to draw what that is, but you should know what that flow net is. Very nice question that you have asked. Some more question? So, this is okay. Let me just my TAs have asked me to take your attention to a point. Actually, first of all, they are properties, they are orthogonal to each other, which we have actually derived also in one of the questions. For example, this is phi 1, phi 2, phi 3, and this is psi 1, psi 2, psi 3. So, you see the angle between them 90 degrees, they are orthogonal. You remember in the we have said M2 and M is equal to -1. So, this is what the flow net is about. I am going to erase this now and go to the screen. Is it anyone online or everybody left? Okay, seems we have another question. Ila Murugu. Is asked why in steady flow stream and path lines are identical, because in steady flows the velocity vectors at different instants do not change, there is no change with respect to time. Ila Murugu. I think we are reaching the end of this session. I hope you have understood the 4 weeks lecture that you have gone through. Do not get worried if you have scored less in the assignments, you will get more chances first of all. Secondly, make notes, as I think Charlie does, and Ila Murugu also does that. So, if you make notes, revise twice or thrice, solve some questions from any of the fluid mechanics objective type or true and false type questions, I think you should be very easily able to get good marks. So, okay. So, Ankit Gupta has said, sir, I need to know what is the difference between Pascal's law and hydrostatic law, basic difference. Okay. Fair enough, I will just tell. So, what is hydrostatic law? Hydrostatic law says that P is equal to rho g h or H is equal to P by rho g, whereas Pascal's law says that P x is equal to P y is equal to P z, that is about the static fluid. All right, this is the basic difference. Okay, so I think you have noted it down, so I will just clear it and no, sorry, and go back here. So, Charlie asks that your gives feedback. Your lectures are very understandable, but I have problems while solving assignments, especially numerical. In some numericals, I can't find how to solve them. So, first of all, thank you that you are able to understand the lecture. Secondly, see, practice will make you perfect. Okay. If you solve again once more the type of numericals I solved during the lectures, I think there should not be any problems, but just in case if you have more problems, take a fluid mechanics book, solved example and then try to solve the unsolved examples, and then you will get an idea. If you solve more number of problems, you will, after seeing the problem, you will be able to understand how to attack or approach that problem. All right, first step is always finding which topic it belongs to. Are we talking about fluid statics? Do we have to calculate the pressure? Do we have to calculate the force? What are we after? Does this question involve the in the inclusion of surface tension, whether we have to find the velocity and acceleration. So, those things you need to understand, and I think by practicing more problems you will be able to do that. Ankit Gupta has said. So, Ankit Gupta has said, are the statements, okay, are the statements contradiction? No, actually not. Hydrostatic law gives the static pressure, all right, and Pascal's law says that the pressure at a point is equal in all directions for a static fluid. So, that is the basic difference which we have written in terms of numerical. See, this course is more about how to be able to solve the problems, and your question is very true about the laws, but both laws in principle are really different. P is equal to rho g h is given by the hydrostatic law, where Pascal's law talks about the qualitative qualitative aspects of this law, that P x is equal to P y is equal to P z, and that at a point the pressure is independent of the direction. Do we have more questions? So, thank you so much for taking out time and attending this live session. Was very much intrigued by some of you who have asked very decent and good questions, and I am looking forward to our next session. Please revise, go to the lectures, do not wait for that live session. You can always ask us about the doubts in the forum, but just in case if you want me to answer your specific question, I will be available in less than 3 weeks or around 3 weeks from now on for the next live session. It has been a pleasure. Thank you so much. See you next time.